they are not aware of their responsibilities. The system has a limited effect on maintaining a safe operation and preventing accidents. The energy isolation we have will be of little benefit in maintaining safe operation and preventing accidents if all the people who are part of the energy isolation process do not know their work. If they are not informed about the permit or the isolation certificate, then energy isolation can make it difficult to secure our work. Our work may benefit less from this. To make this process effective, it is most important that all our ISAs and IOs have a good understanding of their job descriptions, roles, and responsibilities so that the energy isolation process can be made effective. During this, while working, our people should not be exposed to any kind of unwanted, unplanned incident energy release and should be able to execute their work safely. The roles and responsibilities of the Area Authority (AA) include approving all the isolation points to be implemented regardless of discipline after being consulted by the relevant discipline isolation authority. So, if you have to do any work or activity in any area, you will need to isolate all the relevant points accordingly. The responsibility of the Area Authority Shift Controller is to ensure, as an AA, that if it remains mechanical, your PA will be its ISA. If it remains instrumentation, then the instrumentation supervisor will be its ISA. If it is electrical isolation, then the electrical supervisor will be its ISA. If a poster is made, your area authority, your shift controller, if approved, will be your ISA. They will determine which association compact we need. The AA Area Authority has overall responsibility for ensuring that all isolation points have been properly implemented. The major responsibilities will be carried out by the AA Shift Controller, who must ensure that all types of energy are properly isolated. Integrity should be checked, zero energy demonstrated, tested, and confirmed. And this should be confirmed by the SO in the isolation confirmation documentation prior to work execution. So what needs to be done is that the SO, who will be your area operator, must ensure that all types of isolation have been properly confirmed as isolated. The confirmation certificate will then be issued to ensure that permanent leave can be granted. According to this guideline, if you have any questions, you can ask me in the comment section. It is the responsibility of the area authority to ensure that the necessary isolations are carried out. Obtain information from the relevant authority. Identify them so that the area operator, who is the SO, can go and ensure all the necessary isolations and have them verified. And the roles and responsibilities of the SO or isolation authority. So they can go and verify whatever isolation they have. What will be the roles and responsibilities of the ISA or isolation authority? A person with overall responsibilities, someone who has complete authority to ensure the correct implementation, who has the authority to ensure that the implementation is correct. Certification should be there before isolation is applied and prior to any intervention. Before starting any work, they have complete authority to ensure that isolation has been properly implemented and its certification has been properly validated. This IT isolation authority is the ESA, a competent person with detailed knowledge of the facilities. The ISA should have complete knowledge of which facilities are attached to our site. Role development cross-mandate to their discipline, where and which isolation is required with my site. And equipment, all these things need to be ensured and implemented by the ISO, who will be the operator, possibly a PE. The ISA, Isolation Authority, can act in the cases of ISO. The ISA itself can also be the ISO to install isolation if required. Some isolations will not rely on the ISO. The ISA will take ownership of it, verify and ensure the isolation. So the ISA is the isolation authority that will determine where and at which point we need isolation for any facility, and it will communicate its command or identification to the ISO, the isolation operator, so that they can verify the isolation there and implement the isolation there. What will be the roles and responsibilities of the ISO or isolation operators? the person responsible for field operations of the East, and in case of electrical isolation, the field electrical technician competent to work on electrical shelters with high volt electrical isolation record, DCO high volt certificate. Okay, so the isolation operator will be your field operator, your area operator, your permit issuer. It could be your PE from the ISA isolation authority, who is determined with the isolation asset and the cubicle. The responsibility of the ISO is to ensure, verify and rectify all isolations there and to implement them. If electrical isolation is to be done, then your field electrical technician will be your electrical ISO. The ISO cannot be a job performer. The ISO cannot perform GP work for the main permit on the same permit for which they are the isolation certificate holder. The main permit or one is the same as the one for which the isolation certificate is being verified, for which the equipment is being isolated. The certificate that has been attached with the permit after verifying the operation. ISO cannot work for the same permit, just like JB will not be JB. For that GBO, job performance should be separate. What will be the framework of the energy isolation system? Isolation and de-isolation requirements will be documented. If we need to isolate somewhere or de-isolate it later, all its requirements will be documented. An Energy Isolation Certificate (ICC) will be attached. The Energy Isolation Confirmation Certificate will have all necessary supporting documents and information. What documents can be included? A full description of the type of isolation required with markup. For the equipment or asset we need to work on, the proper type and proper marker of the energy we need to isolate will be mentioned there. Unique identification, name and number for each valve, pipe, instrument and electrical equipment will have a specific number and name. Method and sequence of isolation. We will have the method of how to insulate, blind, how the process is being controlled, whether it is being done electrically or pneumatically. All these things will be clearly mentioned there. Zero energy verification requirement will verify the energy first. Next, provision of independent verification of isolation. Zero energy demonstration, which will be the responsibility of ISO, PI or the operator. Zero energy will be demonstrated by applying a lock and then ICC will validate it live. The isolation certificate will confirm that all our isolation is 100% complete. There are chances of zero energy being restored there or any source of energy has become zero. The energy isolation certificate is the first certificate. We will have a process instrumentation and mechanical energy certificate. All types of equipment, any energy isolation will be taken, insured and confirmed on a single certificate. Process mechanical instrumentation isolation is combined on a single certificate. All three are combined on the same certificate for all details related to the separation of plant and equipment from every source of energy. According to these, any pressure source we have will be pressured and its update will be taken on a single certificate. Pressure, mechanical instrument and control. If we have closed any valve with mechanical and electric control, it will also be on this. If we need to do blinding somewhere, if we manually close the valve, it will also be on this. If we have done mechanical isolation with the process and disconnected or bypassed something in the instrument, its control will also be on this single permit, in such a way that the separation is secure, and it will be ensured with this permit that any energy separation blockage or stoppage will be verified, ensured or secured according to this permit. Electric Energy Isolation Certificate (CONUR). So if we need to isolate electric energy from any plant, equipment or process, we will verify, ensure or secure it on a separate certificate. So for any electric equipment we have, if our electrical department comes and isolates it, they will place a lock on the electric isolation point and also install a tag with the lock, which will have all relevant information. This is to ensure that during the execution of the job, no one unintentionally or unauthorizedly restarts this source of energy or electric isolation, which could be dangerous for our people working on it. 9 steps of the energy isolation process. We will specifically discuss these 9 steps according to the energy isolation process. So, what is the first step? It is work request and planning, where we determine which equipment we are working on. In the planning phase, we will discuss which pressure rise sources we might have for working on that equipment, so that during the work we can isolate all phases, all resources, and all types of energy. Identify and approve control. We need to properly identify it with a tag number, equipment number, or our line number, and determine where approvals are needed, where the line is coming from, where the process input is, where the output is, which are the electric equipment, which are the process valve controls. We need to identify what the controls will be and where approvals are required. Then, work site control implementation. Once we have completed our planning and identification, when we go to work on the site, we need to ensure that all our tagging is proper and correctly done as per the blind list as per identification. We need to actually go and isolate all those points according to the control measures. The next step we have is the authorized PTW, meaning once we have identified and isolated any energy source, we need to bring it onto the ICC Isolation Confirmation Certificate. Until our Isolation Confirmation Certificate is validly attached with the permit, our permit will not be authorized or valid. After that, communicate, control and authorize clearance to commence work. Our PI, our operator, will ensure zero energy demonstration by coming to the area. Only after things are properly communicated and cleared can you start the work. The next step we have is dynamic risk assessment. Before you start the work, you need to revise a method statement. You need to review how to secure, rescue, and reduce the risk level for our people if any source of energy accidentally restarts by mistake. Next, we have work suspension, extension, and handover. In any condition, if we encounter a situation where work needs to be suspended, it could be an emergency condition. We might have some requirements it might be ignored by us, and we may need to restore some source of energy for another process. So in that condition, in what condition will our work be suspended? If we need an extension for a task, what process will we use for energy isolation for the extension? And after de-isolating, once the work is completed, how will we properly hand over things? The next step we have is closure and handbag. When we have finished working on our equipment, it is our responsibility to de-isolate it as per blind list, tag list and all the information we have isolated. After de-isolating it, our JP will reinsure it, then our permit issuer PI will reinsure it, then our ICC Isolation Confirmation Certificate will be closed, and with that we can give the handbag and hand over. It will be closed, and with that we can hand over the handbag. Under asset owner controls, the energy isolation we had could be equipment, processes, mechanical, instrumentation, or electrical isolation. After the work is completed, proper closure and handover of the handbook, all controls will be assets that your shift controller will be able to manage from their office. No pressure valve will be isolated or blinded ahead. None of our electrical equipment will be turned off. It will be set back to automatic mode from manual mode, and the stop function will be engaged. We have restored normal conditions. Steps for energy isolation included work request and planning, control identification and approval, work site control, permit approval, pre-job communication, dynamic risk assessment, work suspension, extension, handover, and closure. Operations and planning identify and approve controls, work site control implementation, then approval and authorization in the permit to work, then communication before the start of the job, followed by dynamic risk assessment, then work suspension, extension and handover, and finally closure. Hand back to the PI operator, and then ensure that all our things are controlled by our asset owner and our shift controller from their office. For the energy isolation process, what things do we need to identify? The first thing will be the hazards and the risks associated with isolation. If we are going to perform isolation, what dangers might we face against it? What is the risk level of the dangers against it? To what extent or scope can our people be affected by it? Secondly, baseline isolation. 1. Do we require a baseline for isolation? Or do we need minimum isolation standards? You need to completely shut off the source of ignition or the source of your energy. Or can you temporarily block it to proceed with your work? For this, there should be a relevant Energy Isolation ICC, Isolation Confirmation Certificate. Opposition and energy isolations require a certificate. So for this, there should be a relevant Energy Isolation ICC, Isolation Confirmation Certificate. Net AA. We need a baseline for isolation or minimum isolation standards. You need to completely eliminate the source of ignition or the source of your energy, or you can temporarily block it to proceed with your work. For this, there should be a relevant energy isolation, ICC, Isolation Confirmation Certificate. That must be correct. GI, For example, we have two types of isolation certificates, electric isolation and process isolation. We should never have process isolation on an electrical isolation certificate. Identify the work scope and direct the isolation requirements to the concerned isolation authority. If we need to perform electric isolation, our electric isolation authority will ensure the isolation. It should not be on the electrical isolation certificate. Identify the work scope and direct the isolation requirements to the concerned isolation authority. If we need to perform electric isolation, our electric isolation authority will ensure the isolation. Similarly, for process, mechanical, and instrument jobs, it is the responsibility of the relevant isolation authority to ensure that the proper equipment or source of energy is isolated as per the appropriate isolation certificate. So when we need to perform energy isolation, we will have to conduct a job safety analysis for both the isolation activity and de-isolation in this particular activity. So when we need to perform isolation, this step requires conducting a JSA, job safety analysis, to implement isolation requirements and cross-checking DI's isolation requirements. We will have to conduct a job safety analysis for both the isolation activity and DI's isolation in this particular activity. What potential hazards could there be? What hazards will our people be exposed to? What is the level of these hazards? How will we control them? How will we execute the work safely? The JSA should cover all the stages of the isolation activity. So for the isolation activity, all the steps and stages should be covered within the JSA. So for the isolation activity, all the stages such as all things should be covered. Preparation work for the isolation. And if we need to shift any material for the isolation, we must consider all these things while creating our JSA. If we need to take some material or flanges etc. to a height, if they are heavy weights, if mechanical lifting is required, all these things should be covered within our permit where the JSA will be attached. Installation, removal and proving of isolation. When we need to remove our blind or loban, when we need to remove the spacer and install the blind on the anode, and when we need to open the drain valve to demonstrate zero energy. All these activities expose our people to certain hazards. The control measures for these hazards must be mentioned within the JSA, ensuring the integrity of the isolation. When work is being carried out, we need to ensure through lockout, tagout, that all isolation sources are properly locked and tagged. During the work activity, no unauthorized person should access and de-isolate it, so that during the work, our people are safe. During work, our people should not be exposed to any kind of danger. Whenever we have to test any equipment during energy isolation, the back pressure should not affect our source of energy or our isolation in any way. If our people have to face any danger during this entire procedure, then such things should be covered within it. When we have completed all our work and need to hand over the plant after the isolation, we must also consider that no isolation remains blind there, which could be dangerous for our process or work. Therefore, all such hazards and things must be considered within our job safety analysis, including all processes and steps of isolation. It should be ensured that its control measures are properly communicated. For energy isolation, the highest reasonably practicable standard of isolation should be used in all cases. Mechanical isolation must be ensured for these two activities. Firstly, confined space. Entry. B. Any work that requires us to enter a confined space must be ensured. There we will need isolation. Closing it will not be enough. We will have to blind it. We will do a second layer of isolation, neck, flame, spark, potential. We have to do it in a hazardous area, energy, ignition. We have to block, stop, isolate, double isolation. Isolation, we will ensure our work can be executed safely. We need to block, stop and isolate the source of energy or any ignition source. We will ensure mechanical isolation, double isolation and positive isolation. Any energy isolation sawn must achieve or meet the baseline or minimum isolation standards. The first is positive isolation, also known as mechanical isolation. This involves the removal of the spool and fitting of a blind. You need to place a blind in front of it and apply positive isolation with double protection and fitting of a speed. There, you need to double layer protect it with a speed and speed spectacle blind. You need to perform its positive isolation or double isolation. Next, we have approved isolation, where we have closed any process valve, whether it was electric control or pneumatic control. To ensure its effectiveness, we have vents or a bleed point from where we check our drain point to verify our isolation. The third type that we will come across is non-proved isolation, a valve isolation that we do not have any provision to ensure its effectiveness. We do not have any source from which we can check, review, and ensure the effectiveness of energy isolation. So if you have any questions about this slide, what would be positive isolation, what would be proven isolation, and non-proved? Isolation will be and non-proved. What will isolation be? What will proof isolation be? And what will non-proof isolation be? Hazard factor assessment tool. Whenever we need to perform an isolation, we must ensure the use of the hazard factor assessment tool before proceeding with the isolation. According to this, any isolation we perform will greatly help in achieving the recommended safety standards for isolation. We need to check what level of isolation is required. We need to consider which factors are relevant for the isolation. Do we need to go with the baseline or follow the management standards? Do our people need positive isolation, proof isolation, or can we work with non-proof isolation? The purpose is that whenever our people are involved in any activity, all types of source energy related to that activity should remain isolated at all times. During the start of the work, no one should unintentionally or unauthorizedly access and restore it. In line isolation, if we have to work on any equipment, there can be multiple types of energy related to that equipment that we need to block, stop, or suspend. There can be toxic fluids, failures, gases, chemicals, liquid and gases in the film. Or we might have fire water, portable service water, or steam. We need to stop and isolate multiple types of energy. For this, we will need baseline isolation recommendations, which will depend on the pressure, the flow, the credibility of our equipment. And then the most important factor will be the pressure. It will depend on how much pressure, how thick, and what the diameter is. If we have a fluid coming in with a larger diameter and lower pressure, we will need a different type of isolation recommendation. If we have a fluid coming from a pipeline or a vessel with a smaller diameter but higher pressure, it will depend on whether it is a toxic fluid. After multiple types and multiple pressures, we will need either single isolation or positive isolation. Similarly, for fuels, gases, oils and chemicals, the baseline recommendation will depend on the pressure. The higher the pressure, the more it will be required. We will have to ensure double isolation or positive isolation. We will discuss the baseline isolation in more detail in the next videos. What is the baseline isolation standard? For any task, we must fulfill the minimum isolation standard. Under what conditions? For example, the minimum acceptable isolation standard for hot work and blinds. If we are to perform hot work on any active, any service line or any equipment, we will not record single isolation for it. We must meet the baseline isolation standard there. It is mandatory to do so, where only a single valve is provided in the isolation barrier. If there is any place where there will be a single valve for isolation, total barrier. If there is any place where there is a single valve, then this will be a barrier. What needs to be done for that? It could be toxic, acutely toxic material, or any material with a pressure above 4 bars, or the material is above the flash point, where the concentration of the material is higher than its flash point, or the temperature of the material is above 60 degrees. So we should not control all such isolations with a single valve. We must also mandatorily install a blind on it. We need to ensure positive isolation, mechanical and double isolation before further work can be executed. Before starting work, we have a minimum requirement. Single isolation is the minimum required, but baseline isolation. We must ensure this isolation standard before starting work. Which activities where our pressure will exceed 4 bars could be acutely toxic, above the flash point, above 60 degrees temperature, or any hot activity we need to perform in any pipeline or equipment? For that we need to maintain the baseline isolation standard. Hot. What will be the role of the iWave team in energy isolation? So whenever we need to submit any work plan or works for preview, it will be received by the integrated work activity planning team. After that, they will review it and identify whether isolations are required for safe execution, whether we need isolation to safely execute the work or not. If we need to apply isolation for it, Then the scope of the isolation cell will also be defined within it, specifying where the isolation needs to be done and what parameters will be defined as per the iWave team integrated work activity planning team. The first thing to consider is the system or equipment to be isolated. Which equipment do we need to isolate? Then what will be the location of the isolation? We need to close the main control valve. We need to disconnect the energy isolation from the main panel. After this, installation in the region will follow. Why is it necessary? During our work for our people, what type of energy, in what sense, and how much exposure was there? And finally, what hazardous material could have been involved in our activity? Our people have properties that, due to isolation, have prevented exposure during work execution. So these things will definitely be considered. Where do we need to do insulation? And on which equipment? What was the reason for insulating the item? What will be the properties of the source of energy and its hazardous substances with which we need to protect our people during work execution? If we have isolation requirements for working with any equipment, we minimize. Due to isolation during work execution, we have protected our people from exposure. So these things will necessarily be consolidated with us. Where do we need to perform isolation? Whose couple needs to be isolated? What was the reason for isolating the item? What will be the properties of the source of energy and hazardous substances from which we need to protect our people during work execution? If we are unable to fulfill the minimum isolation standards required for working with a piece of equipment, or if the overall risk of the job is increasing, what should be done in such a case? A formal risk assessment shall be required, meeting the following minimum requirements. There should be an FR, a formal assessment should be conducted. Which major points should be discussed? The first point is satisfaction from the assessment team. The team conducting the risk assessment should be satisfied that the selected isolation control has reduced the risk to an alarm level, meaning that the isolation we have implemented has reduced the risk of our people being exposed to this source of energy to an alarm level as low as reasonably practicable, to a level where we can work from a certain region acceptably. The second step is the concentration of overall risk security. We need to consider the risk within the framework of the FRA that our people might face if we are not controlling the isolation to a minimum standard. If there is an energy leak, exposure, or restoration, what will be the risk level of exposure for our people? The next step is the concentration of alternatives, shutdown or deferral. We should shut down a piece of equipment. We cannot isolate the source of supply from where it is coming, so we need to shut it down from there and temporarily defeat it. The next and last point that we need to consider in the FRA is the concentration of additional control. If we had to close a supply valve somewhere and we are unable to properly isolate it from any region, we controlled the valve. If we are unable to apply mechanical isolation or double isolation, we can go and close their main control valve, which will ensure double isolation for us. For example, if we have a sulfur pit, we need to close all the service steam valves for it. If we are unable to close these valves here, we have closed the valve but cannot insert the blind. Then we need to close the main control valve of the service steam. This will ensure that when our people are cleaning the sulfur pit, they are not in any way exposed to steam. We need to ensure double protection. These are the points that, under any condition, if we are unable to achieve the minimum standard of isolation, passive isolation or double isolation, we must conduct a formal risk assessment. Within this, we must necessarily consider and implement these four major points. It is necessary to implement them. Approve control of energy isolation. The isolation requirements are confirmed and should be approved. WMA confirms the end and viral. Whenever we have to work on any equipment, within our working plan, we need to identify which sources of energy we will need to isolate and which isolation standards we need to meet. So once all these things are confirmed, the authority will give its approval. The ISA, Isolation Authority, will respond by giving its approval. Before authorization, he shall be responsible for ensuring certain things. Consider all aspects of the work planning, all elements of your planning, your execution, your plan, your drawings, your certificates, everything should be complete. Your planning, monitoring. Your pre-work should be complete. The operation resources and requirements, the tools and equipment you are going to use, the machinery and vehicles you are going to use, everything, the training of your people, the competency of your people, your job craft competency, all these things should be complete. You should have enough staff as a supervisor. And if there is any work happening in your area simultaneously, if there is a simultaneous operation, whether it will be routine or non-routine, whether the activity you need to perform can be done alongside this other simultaneous operation or not, all these things should be pre-planned. Determine if independent verification is required. Whether zero energy demonstration for energy isolation is required or not, you need to make these decisions beforehand, consider them, and only then will the Energy Isolation Authority approve proceeding with this isolation. Anyone competent and with a WMS system can carry out independent verification as identified by the authority. The Isolation Authority will justify to us, we will recommend it to anyone competent in WMS who has the knowledge and experience to identify it, to go and verify, check, or ensure the zero energy demonstration. Process M, mechanical and instrumentation isolation. Installation of mechanical isolation involves two stages. Whenever we have to perform isolation mechanically, there can be two stages. First, you will have valve isolation to control the valve, and the second will be mechanical isolation. Here, first of all, we explain both types of isolation in this paragraph, and later I will provide you with a short explanation for better understanding. Well isolation is a process isolation that enables the insertion of a mechanical isolation downstream to the initial isolation. Whenever we need to control a valve using some process, we have to operate it centrally from the System Area Authority's office. Whether it is controlled pneumatically or electronically, it will fall under process isolation, which will ensure
If you have electronic control, it will come into your process isolation, which will ensure that you have installed the mechanical isolation downstream, thereby isolating us from the source of energy. Next, we have mechanical isolation, physical isolation, which requires stable personal protective equipment to mitigate against undetected failure of the initial isolation. We controlled the valve and isolated it, and then we also placed a blind ahead of it so that if our valve fails or if our process isolation can leak or fail, our blind, which was our dead end, will ensure that no source of energy or supply can come and expose our people to harm. During work, our people remain safe from this type of energy source. Proving the integrity of isolation, how valid and effective our isolation is, what process do we use to check and ensure its integrity. So first let's talk about process isolation. Valve isolation does not always provide a leak tight seal. Any valve isolation we have is not always 100% seal tight. We need to timely check the pressure build-up to ensure there is no leakage inside. Pressure gauges should be fitted to allow for the monitoring and venting. For process isolation, where we need to hold pressure and maintain it, we will need to install pressure gauges to ensure the integrity of the isolation. To check the integrity of the isolation, the subject isolation points should not leak. There should be no leakage of any kind from there. Whatever fluid or pressure is present should remain at a certain fixed amount for a certain time. If your limits allow for a pressure drop once every half hour, that is not affected and we will not consider it a genuine leak. But if the pressure leaks more than once in half an hour, we will consider it a leak. We will not accept the integrity of this isolation and will not be able to work on it. Proving the integrity of isolation for electric isolation, our equipment is properly isolated, the energy source is suspended, stopped or blocked. How will we ensure its integrity? So first of all, we have a point circuit breakers. If there is a circuit breaker in between our power supply, we will switch it off. If that breaker ensures that all kinds of supply have stopped coming in, then we can ensure integrity through automatic isolation. Next, we come to the point of fuse installation. If we have any power supply and we have installed a fuse in it, we will place any fuse in parallel. If we need its physical isolation, we will physically remove the fuse from the circuit to isolate it from the power supply line. If we remove it, we will get additional support against the breaker, indicating that our breaker is also off and we have removed the fuse as well. We have the integrity of electric isolation 100% safe. The next step will be, what does disconnecting mean? We had turned off the breaker. After that, we physically removed the fuse as well. Now we have to test it. To demonstrate zero energy, we will turn on the power supply of any electric equipment. After turning on the power supply, we should have a digital multimeter. We should have a tester that will monitor the current input, the current supply, or the flow of current in terms of voltage, amperage, or current. The next step involves voltage indication lights. Even if we have a little voltage, the lights will indicate that energy is being restored in our equipment. We will know how much voltage is coming and all other details. What comes last for us? Operation of the starter mechanism. If we need to send a stop signal from a remote area and shut it down, we will use all necessary measures while limiting these things. We will be able to ensure when our people are working on any equipment, component, part, or device. At all times, we must ensure that our electrical isolation is 100% secure, safe, and blocked. The electric supply should be stopped. If you have any questions about this topic, you can ask me in the comment section. For more videos, I request you to subscribe to my channel. Don't forget to press the bell icon so that you receive notifications for the next video on time. According to the ADNOC WMS Energy Isolation Module, we will discuss in detail the standard guidelines for energy isolation in the next video. So the important points we are going to discuss, the first one will be process ventilation. How we have to carry out process ventilation and test, and how to ensure it. What will be actuated valve draining, meeting, pulsing, and flushing? What will be the bleed points? What will the vent system be? How do we have to test our isolation, braking containment? If we have any leakage, how do we tackle it? Proving isolation at the first flange brake. How do we perform a verified test of our isolation? Securing the process. Isolation. How to perform double isolation? Self-isolation. There will be some equipment that will need to naturally, self, or individually waste a state. At the end, we will discuss the most important topic, lockout tagout, how to implement, and ensure LOTO. Shut it down and turn it off. This remains the best or safest method you have. What is the second method? Isolation and commissioning of a localized section of the pipeline where work is being done on one section and we are getting a controlled process on its back. It can be insulated there. We can place a blind ahead of it to achieve positive isolation. Mechanical isolation. Meaning to say, if work needs to be done on a segment, if we can separate and insulate it, we will do that too. Otherwise, what is the best thing done? Complete pipeline, including the source of energy, will also be insulated so that we can work securely and safely on the pipeline. We will be able to verify the insulation. For the insulation process, a permit to work is required, as in certain situations we need a permit to insulate. What work needs to be done, where it needs to be done, on which equipment, at what time, what hazards, what control media, which tools can be used, meaning you need this for insulation. A permit will be required to perform insulation, so for which applications a permit will be needed is mentioned in 3 sections. For applying, mechanical isolation involves placing a blind in any area or pipeline support. Physical isolation, mechanical isolation needs to be done. For that, a permanent requirement will be needed. For all intrusive electric work, if we need to perform any critical complex electric work, a permanent requirement will be needed. To perform electric isolation, verifying or ensuring the electric station is not necessary. To physically practice it, a permanent requirement will be needed. Third, we have the PTW requirement for an isolation activity as per the IWeb team. Any situation that is added per the IWeb team will recommend which work requires a permit, or if the activity is being planned as per the IWeb plan, then as per the integrated work activity plan recommendation, a permanent requirement will be needed. So isolation, mechanical isolation, electrical isolation, and every activity recommended by the IWeb team will require a permit to perform the isolation. Electric isolation. To electrically isolate any equipment, component or machine, the ISO Isolation Authority, which is a technician from the electrical department, will come and be authorized to isolate it upon the recommendation of the ISA Insulation Authority, who will be the electrical supervisor in electric isolation. Ensuring the performance of isolation based on their identification or mentioned indication will be the responsibility of the electric ISO. Low voltage isolation. Any equipment we have that operates on low voltage electric supply and competent means what? Someone who has training, knowledge, experience, certified, who has training, knowledge, experience, certified after training with a build certificate, and authorized and has permission for this authorization. ISO electrical technician who will be ISO can apply low voltage electric isolation. The second type comes high voltage, above 1000 voltage alternating current. In this too, the same electrical ISO or electrical, your technician will be authorized to come and isolate the supply of low voltage or high voltage electric equipment. Proving the effectiveness and integrity of isolation. How will we ensure the effectiveness of any isolation? Prove it. So what is the first thing? Integrity of isolation hardware, the material from which you are doing isolation. What is it made of? Approved material should be used. Adequacy of the arrangements. You should have measurements before putting the blind. Which gasket to use, which bolts to use, how much torque to keep, what will be its quantity and strength. All things should be arranged beforehand so that when you do isolation, you can perform a good action according to proper arrangement. It will base on how authentic your isolation is, how effective it is. The next point is proving and monitoring of isolation. When we have done isolation, how do we test it? So the first point we have is opening of the bleed vent or drain valve. If we have a drain valve ahead of isolation, we can simply open it and do pressure testing from there to see if any material is coming, if any supply is running, whether it is properly isolated or not. Next we have pressure build-up test. We have gauges installed from which we can check the pressure build-up behind, and the pressure ahead should be 0. If pressure is showing, it means our isolation is not ensured there, our isolation is not effective. Similarly, if we talk about electric isolation, whatever our electric circuit will be, equipment component, anything, we will be able to ensure it by manually operating it. If it is operating, it means our isolation is not effective, our isolation is not proved. If it is not operating, then we have done its physical examination, ensured zero energy demonstration, confirming that our effectiveness, our isolation is effective. Lockout, tag out. One of the most important topics in energy isolation is whenever we need to isolate something, whether it's electric, mechanical, PODI, or any type of process energy, we need to place a lock there so that no person can accidentally store any type of energy during the activity. If you turn off the electrical equipment, you will put your lock on it. The operator, as they say, will then put their lock to ensure the work is finished. Even if the JP lock is removed and the operator also removes their lock, energy can still be stored. So we will properly lock any valve control to ensure that no type of energy is accidentally stored during the activity. Along with this, the most important thing is that when placing a lock, we must also display a tag there which should have all the relevant information mentioned on it. There is a visual identification that this device has been locked, for what purpose, under which permit, and for how long the energy is expected to remain isolated. Who is the authorized person to come and restore it, so that this can be double checked and ensured that no unauthorized person restores the energy during the activity. Energy isolation confirmation, and independent verification. Who will confirm it once we have done the isolation? And who will verify it, and how will this be done? So the first point is the confirmation of isolation. The de-isolation operator, who will be the ISO, whether it's electrical instrumentation, mechanical processing, the relevant authorized person for each job will be called the ISO isolation operator to perform the isolation. Performing the individual isolation, each isolation will be done individually, and the shelf sign and visual isolation points. All the isolations will be confirmed by signing on the isolation certificate according to their tag numbers confirming that I have isolated all the individual points that I am signing off on. Next is the verification. So independent verification of each point will be done by different spread verification. The operator, who will be the ISO, will demonstrate zero energy to the job performer, JP. For zero energy demonstration, you can use vents, bleed valves, gauges, or operate an electric component. In independent verification, the kumbekoiki, it is also required to ensure testing requirements.
We can use a blade valve, though, use a gauge, or operate the electric component to use it. Independent verification of what is also required to ensure testing requirements are met and the LOTO procedure is aligned again with the plan and approved procedures. Both signatures shall be recorded on the certificate. So when your energy isolation independent verification is done, if LOTO was applicable and approved previously, it should also be applied. After that, both your PI and GP signatures must be on the isolation confirmation, which is the IC certificate, which we refer to as IC. For the isolation confirmation certificate, to be more authentic, the PI lock number and JP lock number must be mentioned on the IC. Final sign off on the isolation certificate. So first of all, what we had was the ISO, our ship controller, who provided us with the isolation points indicating where the Fletcher should be to perform this task when our operator, the ISO, completed all those isolation points. Independent verification was required where zero energy demonstration was needed, and the GP performed that zero energy demonstration, ensuring it. After that, both signed their signatures on the form. Both signed the ICC, affixed their signatures. After verification, it will proceed to the area authority. The area authority will verify everything to ensure that our isolation points have been properly isolated at the right points. A private demonstration has been conducted. The signatures of both parties were applicable there and have been done. After that, the area authority will sign it and our isolation confirmation certificate, the ICC, will become live. Next time, our task is to make the associated work permit live. So until our ICCs are approved, they will not be wild or live, and their associated permit cannot be live in the system as per WS. So we must follow all these steps to make the permit live. The ISR will indicate the isolation point. The ISO will perform the isolation. The ISO must demonstrate zero energy to the JP. The ICC will be signed. The AA will approve the ICC. Only then will it be linked with the ICC permit. The permit will be wild, live, can be approved, and we will be able to start work with it. Z. Before starting work, a zero energy demonstration is standard in the WMS of the permit to work in accordance with the PTW standard. The permit issuer, your area operator, shall demonstrate the zero energy of your isolation, the type of source of energy, and provide a physical witness. It will ensure, as applicable, if there is a requirement, the job performer, before starting the work, will ensure that the permit issuer verifies or witnesses that the type of energy has been properly isolated. How will the JP accept it? The job performer accepts that he witnessed the demonstration of zero energy by the permit issuer. He will accept it when he receives the permit. This is covered by the signature of the JP on the permit. So when they have received the permit, it means they have witnessed, ensured, and verified the zero energy demonstration if it was applicable. This guarantees us that when we are working, all processes are in place. Before starting the work, we have ensured that no type of energy will be accidentally restored during the work. It will not pose a threat to our people. Personal lock. Each job performer shall apply and provide the personal lock number on the respective work permit prior to the commencement of work. After the zero energy demonstration, every JP will apply their lock where the PI's lock is, where the ISO has placed a lock, and where the area operator has placed their lock. The JP's lock number should be noted down. it should be attached to the certificate with their permit. Only then can you start the work. Personal lockout shall be used in addition to the primary isolation and not as a substitute for primary isolation. The JP's personal lock will be an additional control to ensure that all involved parties have locked out and tagged out the isolation. We will never consider it a responsible replacement for primary isolation. The permit issuer's PI's or operator's lock is mandatory for this. Each JP attaches his or her own lock to prevent exposure to energy sources. Every JP will mandatorily install their personal lock along with the PI's lock. They will note its number to ensure that no type of energy is accidentally released during the activity, posing a threat to our people. Dynamic risk assessment process. For energy isolation, it is important to monitor the integrity of isolation on the work site. Monitoring and ensuring the integrity of isolation during work activity is very important for any changes that might prevent the job from being safely completed. If there is any change, leakage is occurring, pressure is being released, or pressure is building up, it can pose a threat to our work and it should be addressed in time. It can become a hawk of danger. To control it timely, to cover it, cool, or to prevent that danger, we have to ensure the integrity of isolation, monitor it, and secure it. Dynamic risk assessment is identified as a continuous process of identification of hazards. What is risk assessment? In it, we identify what the danger is in our work, who can be affected, and what the control measures are. Can we make the risk level as low as reasonably practicable with additional control measures? So, all these procedures during activity isolation need to be continuously monitored. The risk level should not change when assessing. Risks arising due to a change of circumstances. If under any condition we have an isolation leak, excessive buildup, or increased pressure, the gauge is dropping or raising its pressure in an operational environment, followed by actions taken to eliminate and reduce the risk. In that condition, in that scenario, we need to take timely action according to the changes happening so that we can verify the isolation, ensure the integrity of the isolation, or prevent its leakage, so that the activity in progress, the people working in it, are exposed to the least possible risk level. They should not be exposed to any type of energy. How and why should we monitor the isolation? The integrity of each isolation point shall be regularly monitored. If our activity is running for more than one shift, we need to validate our permit in every shift by getting the isolation year data certificate validated before revalidation or making it live. For the isolation certificate to be valid, 0 energy demonstration must be ensured by the PI to the JP. Only then will he sign the permit. Endorse it after the permit endorsement. Once your certificate is endorsed and validated, your permit can go live. Testing and monitoring requirements shall be followed. If we have some energy isolation where there is a high chance of leakage, we will ensure proper energy isolation by using drain valves, bleed valves, or gauges, or by mechanically, physically, or electrically operating equipment. The area authority shall determine the requirements for proving isolation in place for longer than one shift as per the area authority's recommendation. Isolation that lasts more than one shift will be verified and monitored. The frequency of monitoring and the responsible personnel should be identified to ensure continuous monitoring of the isolation as per ISA. At the ad for ISA, we must ensure continuous monitoring, revalidation, and retesting. The ad for ISA, Isolation Authority Recommendation, ISO Isolation Operator will frequently monitor and verify the isolation after each cycle or period. If applicable, the ISO will also demonstrate zero energy to the JP. In this way, we will ensure the monitoring of isolation that is happening for a long time in a shift. Section 2 Test STT is one of the most important certificates. Elements of an isolation scheme need to be temporarily reversed to confirm that work stages have been correctly completed. In any condition where during work activity, POM, we need to temporarily bypass isolation, remove isolation, or restore the energy source, we must restore the particular type of energy with the equipment and check whether the work stage has been properly completed or not. Removing electrical isolation to check electrical equipment during work activity requires a special certificate, STT, or Section 2 test certificate. For example, if we are working on a pipeline, a hot tapping activity to ensure it, we can remove the temporary isolation of the proper pipeline that was suspended and isolated, perform a leak test, check the pressure by attaching a pressure gauge, and perform pneumatic selection. Section 2 test is required at the intermediate stage of the work activity, involving function check and pre-start check. So we need the STT certificate in all conditions where we want to test all stages or function checks or pre-start before work completion. For this, we have properly closed the isolation certification and not handed it over to Control AA. But we need to check the integrity, testing or pre-startup of all the equipment. So for that purpose, we need to remove isolation and restore energy. It means during work in progress, day, any type or source. We need to restore any type or source of energy during the work in progress. Our isolation can be mechanical processes, instrumentation, or electrical. It needs to be temporarily removed. If it needs to be bypassed, then we need STT or a Section 2 test certificate will be required. The isolation process. When we need to de-isolate any isolation, it should be approved on the same initial, Area 30 or AA. Isolation Confirmation Certificate. Once all preparations for reinstallation have been completed and the readiness of the plant for commissioning is confirmed. If we talk about a single piece of equipment, when our equipment is properly boxed up and everything has been verified and approved, then we can de-isolate that particular equipment. But if we talk about the entire plant or unit, when all equipment of the plant and unit has been verified and boxed up, everything is ready. Their individual isolation has been removed. Then we need battery A to ensure everything before removing and starting the decommissioning plant. The operator should remove the isolations. According to the de-isolation specifications mentioned in the isolation certificate for de-isolation, just as we had the isolation scheme approved after planning. Similarly, the de-isolation scheme will also need to be approved. We need to remove all isolations according to the agreed de-isolation procedure in the presence of the supervisor. Some isolations might be included under a specific permit. We simply need to have them de-isolated by the supervisor, but for certain de-isolations, separate permits might also be required if we have a significant elevation. We need a crimp. We have better limits for de-isolations. We had inserted a process ball somewhere, and we need to move it up to insert the ball. So, for all these things, we will require separate permits for de-isolations. Extended thaw period. Isolation which is required to remain in place, even though no work is being carried out within the isolation boundary, may be required for the following three main reasons. Any isolation that is in place, even if no work is ongoing there or no activity is being performed beyond that isolation, we have three main reasons for which we need to maintain that isolation for an extended period. The first reason could be that the task has been commenced but is suspended for a period extending the validity period of the permit. We performed some work but it was not completed and we have suspended it for a long term. By trending, the work has been taken to the next phase, so we will also need to verify the isolation there.
for the standard pair. Print. Next, we have the point that an item of equipment has been installed, but during the commissioning and startup of this owing, some items in our equipment have changed, but the commissioning guard is not being received. Its inspection has not yet been validated. The inspection is due, which is why we have not removed the isolation. The third thing is an item of equipment that is near retirement and is to be isolated pending an MOK to remove it. We had an item of equipment up that had become very old. It has expired, it has been retired, and we need a management of change request to change it. We have management of change requirements, which is why we have not removed the isolation yet. We will take the isolation to the standard pad, the isolation and exit at the prepared isolation. In this, we have two major points. First of all, the recommissioning request equivalent control to those used during the installation of isolation. This means that when we had to do the isolation, all the concerned parties for de-isolation should have the relevant authorized control in place. If any person or any involved party is working, we cannot perform any isolation or de-isolation or decommissioning before their work is completed. Control should recruit a check of all cross-references, permits in force related to that isolation. Before we perform de-isolation, we must ensure that all permits related to that isolation, as well as any ICC certificates, are closed. We can only proceed with de-isolation after verifying the closure of all relevant isolation certificates. We can start the process before the statement of plant and equipment to its operation state. The PTW and approved task reference de-isolation certificate shall be closed out by JPP and signed off as closed and safe to de-isolate by the area authority. What happens is that when we need to shut down an area, we isolate the battery limit. After isolating the battery limit, we start work by isolating multiple pieces of equipment inside. Beyond the battery limit, our unit is divided into more than 1, 2, or even 3 or 4 zones. Each crew may be assigned a particular piece of equipment. Some crews will perform valve replacement. Some will work on piping, and others will work on exchangers. We need to ensure that when we de-isolate the battery limit, all linked equipment ahead have their permits closed, and all individual isolation certificates are completed.